Ever wondered why some AI tools catch hate speech while others miss it? What if the answer lies in how we define hate speech in the first place? Today, we're diving into a groundbreaking study that's reshaping how we think about online content moderation, and why the tiny details in definitions can make a huge difference in AI performance. Hate speech is a massive problem, but here's the catch. There's no universal agreement on what it actually is. Is it direct insults, threats, or does it include subtle biases hidden in language? This ambiguity isn't just a debate, it's a technical hurdle. When AI models like large language models, LLMs, try to spot hate speech, their success depends on how we describe the problem. This research team tackled that challenge by building something new, a modular taxonomy of 14 core, conceptual elements that capture the essence of hate speech definitions. Think of it like a puzzle. Each piece represents a different aspect, like who the speech targets, individuals or groups, whether it's explicit or subtle or what consequences it might have. Here's the cool part. They didn't just list these elements, they organized them into 3 layers. The foundational layer includes basics like target and problematic content. The contextual layer adds nuances, like whether the speech implies harm. And the nuanced layer dives into tricky stuff, like implicit hate or possible implications. It's a framework that lets researchers and developers build clearer, more precise definitions. But how does this affect AI? The team tested 3 popular LLMs, Llama 3, Mistral, and Flan T5, using definitions from their taxonomy on 3 different datasets. The results? It depends. More detailed definitions helped some models catch subtle hate speech, like coded insults, but confused others. For example, adding implicit hate reduced false negatives in some cases but didn't always improve accuracy. What does this mean for the future? It shows that AI isn't just about data, it's about how we frame the problem. A definition that works for one model might fail for another, and the same goes for datasets. The study also highlights a bigger issue. Many existing definitions overlap or mix up concepts like hate speech and offensive language. Their taxonomy offers a clearer roadmap, but the real takeaway is this: the words we use to describe problems shape the solutions we get. So next time you see an AI flagging content, remember, it's not just about the algorithm. It's about the definitions behind it. And this research is a big step toward making those definitions as precise and fair as possible. Thanks for watching. Drop a comment if you'd like to see more deep dives into AI ethics. But here's what's really interesting. The study didn't just look at errors. It also broke down the types of hate speech into 29 distinct categories, like anti-black racism or transphobia. These categories were created by reviewing past research and talking to experts. Yet even with these detailed guidelines, the models still couldn't agree on what to flag. Looking at the data, the numbers tell a story. In one dataset, Llama 3 made over 400 errors when classifying a specific type of hate speech, while Mistral had fewer but different misclassifications. It's like each model has its own blind spots. And when you compare the 3 models side by side, the error rates vary dramatically, sometimes by hundreds of mistakes. So why does this matter? If AI systems can't consistently define hate speech, how can they fairly moderate content online? This research shows that the problem isn't just about training better models. It's about rethinking how we define what we're trying to detect. Next time you see an AI flagging a post, remember, it's not just a simple yes or no. It's a complex puzzle where even the rules are still being written. And that's what makes this research so crucial for building tools that are both smart and fair.